David Smith here with one more Flip Classroom math video. 3 tips before we start. First, you can increase or decrease the playback speed if that helps you get through the video. Second, you can pause the video at any time to catch up with your notes. Third, you can turn on the captions to watch my words go by on the bottom of your screen. I'd like to take you on a trip through some problem solving using quadratic equations. We did one in our last lesson. I think I have 2 for you in this lesson. But first, I'd like to review what we know about quadratic equations, both in words and with an example graph. So this will help anchor you to what's going to come next. So if you feel like you have all this down pretty good, just listen along. If you want to put this in your notes because this is like a good summary of what we know so far, then do that. So let's get started. So, quadratic functions. They make parabolas. Okay? So here it is. I've got a nice loopy parabola right there for your enjoyment. So let's start talking about that. One of the things that we talked about is the axis of symmetry. That is a vertical line that goes right through the vertex. It's called the axis of symmetry because if you mirror one limb of the parabola, it'll reflect and cover the other limb of a parabola. So with the axis of symmetry, really you only need to graph one half of it and then you can just reproduce that on the other side. Of course, if you're using your calculator, it'll just show up on the calculator. Okay, the y-intercept. There's always one. Every parabola has one y-intercept. And that intercept goes right there. It's the point 0, c. And let's get this form up here. ax squared plus bx plus c. That's the standard form for a parabola or a quadratic function. And the c, the number, these two have x's on them. This one's just a number hanging out there. It's always the y-intercept. So if you're in standard form, the y-intercept is just there to grab. No calculation necessary. Okay, let's move on. The x-intercepts are way more complicated. We know that there are 0, 1, or 2 x-intercepts, and that's because a given quadratic equation will have either no solution, 1 solution, or 2 solutions. And those solutions, the numbers that you get from solving that quadratic equation, are the x-intercepts. Now, there's some interesting sub-points about that. First, let's take a look at the graph. What I've done here is I've just marked my 2 x-intercepts. This is where this graph is crossing the x-axis. And there are always some number x. I've put this as x1 and then 0 for y because it hasn't gone up or down. So the y value here is 0. And then I've just labeled this one x2, 0. So these are my 2 intercepts that are there. Okay, let's see. Looks like, okay, so if there's one intercept, then you have some kind of parabola that's doing this. It's just kissing the x-axis like that. So if it has one intercept, that intercept is also the vertex. Okay, so that's a nice little trick to know. If you solve for intercepts and you just get one solution, then you know that that is also the vertex. You just have that. Okay, if there are 2, then the axis of symmetry is always halfway between the 2 intercepts. So let's take a look at our diagram here. Here are my 2 intercepts, and here's my axis of symmetry. Look at that, it's halfway between. It looks like it's halfway between, and actually the math of it will show you that. Now check it out. What I did here is my x1 and my x2 on my graph, I wrote those points here. So these are the points from the graph. The axis of symmetry is just going to be x1 plus x2 divided by 2. That's how you would get halfway between those 2, and that's a way to find the axis of symmetry. Forgot the vertex, David. Let's talk about the vertex. Added that here. Now the vertex is pretty easy to get. The axis of symmetry goes right through the vertex. It has to. The vertex is the turning point. So to get the vertex, the x-coordinate of the vertex is the axis of symmetry. Okay? Now whatever that number is, if it's x equals 3 or x equals 10, whatever that number is, you plug that number in for x in the quadratic function, and it will spit out the y-coordinate for the vertex. So that's what this is all about. Here is the vertex is the point minus b over 2a, that's the x-coordinate, and then f of minus b over 2a. And what that really just means is take this value that you got from using your a and your b in your quadratic function, take that value that's here, that's the axis of symmetry, put the value into the function. That's what I mean by saying f of minus b over 2a. So you take that value, put it in for x, solve it, and you'll get your y value of the vertex. Okay? So that's one way to get the vertex from a quadratic equation. Now, vertex can be either a max or a min. So this one represents a minimum. This parabola graph does not go any lower than that value. So whatever that number is, whatever that y value, whatever that f of minus b over 2a is, that would be the minimum for this graph. In the same way, a parabola that opens downward, the vertex represents a maximum. So that one would have a max. It's the same thing, so it's still going to be f of minus b over 2a, but that number will be a maximum. So I think that covers this board. All right, here's our problem. We've got a suspension bridge that's kind of like, we're modeling this curve of a suspension bridge. You can think of it like, the bridge goes like that. This could be the Golden Gate Bridge, something like that. So we're going to model this curve of the suspension bridge, okay? And it's given by this function. Remember I talked earlier about how some quadratic functions have lots of decimals in them, and this is no exception. It's 0.00097722x squared minus 1.167x. It's just a quadratic function, but I don't know about you, but I'd rather not solve this algebraically. It's just these decimals are pretty hairy. You could put it in the quadratic formula, but again, these decimals are going to give you some grief with the calculator. Fortunately, if you graph it in the graphing calculator, all this stuff becomes relatively easy. So let's take a look at what we're going to do, and then I'm going to jump on the calculator and do that on the calculator for you so you can see the steps required to do that on the TI Nspire. Okay, so the bridge is modeled by this function. X is the horizontal distance, so that's the back and forth. So that would be this distance, back and forth, just like on a graph. And then f of x is the vertical distance, so that's this deal here. That would be our y value. And we could stick our graph, our axes right on this bridge, right like that. And so this would be y, this would be x, and we start counting that way, and we start counting that way, or down. Okay, so what we're going to do is we're going to plot the function, okay? Then the next thing is we're going to find the coordinates of the intercepts, of all three intercepts, and then we're going to determine the axis of symmetry, and then use that to find the coordinates of the vertex, okay? So let's jump over onto the calculator and see how that goes. Here I am. I'm using what's called the emulator, which is a software package you can download and install on your laptop, and then you can use the calculator on your laptop to do these questions. It also occurs to me that if you're familiar with Desmos, you can use that on your computer as well and answer all these questions. However, there's a big problem with those two approaches. You should use your physical calculator because that's what you get to use on the tests, including the big IB test. So if you're not familiar with that actual physical hold in your hand calculator, you're going to be at a disadvantage. Okay, so let's get started. So what I have with the emulator is I have a picture of the calculator on the left. This is fully functional. I'm going to press buttons here, and then I have a blow up of the scratch pad up here that shows this little screen on the left, which is nice and big. So what I'm going to do is I'm going to click on graph. That sets me up for a graph. I'm going to pop over on the calculator on the left, press the menu button, go to graph, entry, edit, and go to function. Now, what I want you to do when I teach this with the emulator, with the computer, the calculator, is you should be following along on your calculator. Don't bother to write stuff down. Just do this on the calculator. And if you get lost, just rewind the video a little bit, watch the instructions, and then make sure that you can follow along on your calculator. Okay, so now what I'm going to do is I'm going to enter that function. So take a look at your notes and see that function that I had up on the board. Pause the video and enter that function. Okay, let's see how you did. That function is 0.0009722x squared minus 1.167x. Now, when I tap my enter key over here on the calculator, get this line. Now, this brings up a very common issue with this calculator. And that's the zooming in and out. This does not look like a parabola, right? It looks like a linear function. That's just because we're not zoomed out far enough. Before I do that, I want to point out also, here's how our function is showing up in the calculator. 9.72 e to the minus 4. That means 9.72 times 10 to the minus 4. Understand your scientific notation, you'll realize that that makes the function we entered, 0.009722. Notice also how it's rounding to 3 sig figs. Additionally, so is this term here is rounding to 3 sig figs because we know we put in negative 1.167. It rounded it to 7. Now, I haven't explored this yet in the calculator, but I'm sure you can change those settings if you want to see more decimals. Or if you want to just see the function without it putting it in scientific notation like that. Back to our parabola. Let's make it look like a parabola. So with the calculator, you can grab, see how when I hover over the axis, I get the little hand? If I click down, and you have to do this on the calculator's mouse pad, and drag it to the left, see how I'm expanding the scale? I'm zooming out basically. As I keep zooming out, there we go. I have a parabola now. And now you can see how it's doing it. Before we were just looking at a little place right near the origin and it was hard to see. I can also click down in a blank area. Notice how my cursor is going to change to a hand and I can drag the graph around. So I can get the graph a little bit more centered. Now I might zoom back in a little bit. And let's show you another way to zoom, okay? I can hit my menu, go to Windows Zoom, and pick zoom in or zoom out. If I zoom in, now see I have a plus cursor. So if I do that, and I'm assuming that center is going to zoom me in right there, there we go. So this is a good view of this function. So when we go back to the whiteboard, I'm going to have transferred this over to the whiteboard because you will be doing that same operation on your tests and quizzes. You can create the graph on the calculator, then you use what you learn on the calculator to put that graph on your paper. Okay, so we plotted our parabola, we plotted our function. Now we need to find the coordinates of the intercept. This happens also on the menu. If I click menu and go to Analyze Graph, what you have to realize is that the x-intercepts are zeros. They're considered zeros, and that's because they represent the places where the solution of the quadratic equation equals 0. So if I click on that, now I have this little trace deal. What I have to do is click down. I'm going to go for this intercept right there. I click down to the left of it and then move my cursor over. See how I'm bracketing it? And I click down again, and now I have the intercept, which is right over there. I can drag this little guy out of the way, and then I can go over here and do the same thing. I'll hit Menu, go to Analyze Graph, go to 0, and drag it across that one too. So our first intercept here is 0, 0. Our second intercept is 1.2 times 10 to the 3. That's what the E plus 3 stands for. Now pause the video and think about what that number is. That number is 1200. It's 1.2, but you move the decimal places 3 to the right. So you're going to move it once to the right, you'll have 12, and then 2 more times to get you up to 1200. So now we have our two x-intercepts. We have the point 0, 0. And again, see how I hover, I get my little hand. I can move these things around for what's underneath them. Again, this is easy for me because I have a mouse on a computer. It's a little harder on the calculator, so you'll have to practice a little bit. I'm noticing another thing that you want to watch out for. See this number here? This threw me through a loop at first because to me that looked like, oh, that's the x-intercept. Intercepts show up as coordinate points with parentheses around them. This is just telling you one of the points on the axis, one of the scale points on that. So we have the x-intercepts. What about the y-intercept? Do I need to do anything to find that? And the answer is no, because this parabola goes right through the origin. And whenever that happens, that point is also the y-intercept as well as one of the x-intercepts. So we're done with that too. The y-intercept is the point 0, 0. Okay, so the next question we had was determine the axis of symmetry. And that is here. That goes right through the vertex. What's going to happen to us is we're actually going to find the vertex first. because the x-coordinate of the vertex is the axis of symmetry. Do this again off the menu button, go to Analyze Graph, and now I'm going to pick either maximum or minimum. This graph opens upward, so that means the vertex is a minimum, so I'm going to select minimum, and now I'm going to do the same kind of trace thing. I'm going to click on one side, and now I'm expanding that range, go to the other side, click down, and check it out. I now have this vertex coordinate point, which I can move into a nice, easy position. And so now we know that the vertex occurs at 600 minus 350. So pause the video and write down the axis of symmetry based on this information. Okay, let's see how you did. If you wrote x equals 600, you're right. Remember, the axis of symmetry is a vertical line that goes straight up and down, and it goes through the vertex. So the x-coordinate of the vertex is the equation for the axis of the symmetry. Go back to the whiteboard and put this graph on there and do a little bit more work with it. Let's look at that graph on the board. So I've transferred that over here. And notice I don't have a whole heck of a lot of information, but I have the necessary information to describe this parabola. So make sure you can do that. The calculator is awesome, can show you everything you need, but you're ultimately going to be graded on what you put down on paper. So I labeled my axes, x and y, and then I drew my suspension bridge hanging down. I marked my x-intercept, which is also the y-intercept there, that's the origin, 0, 0. And then I marked the other x-intercept, which occurs at 1200, 0. So that's that. I also marked my vertex right here, 600, and I have a little boo-boo there. Pause the video, see if you can figure out what it is. If you thought I left off the minus, you're right. That's negative 350. We're down from the x-axis. Small mistake, but gotta catch them. And then finally, I wrote the equation for the axis of symmetry, which is this vertical line, x equals 600. So everywhere on that line, no matter what y is, x is 600. And of course, I drew it so it goes through the vertex. So this pretty much describes the parabola. If you're trying to be really thorough and like meticulous with your documentation, you might write somewhere here, like where there's space, is put the function, okay? Because the function is what is here. Now the function could be figured out from those points. You could back engineer that, but sometimes it's just nice for thoroughness is to write your function up there. Okay, so let's take a look at a couple questions. Here are 4 more questions that can be answered with our graph right there, okay? So I want you to pause the video and try to do all of those. Is this a max or a minimum? What is the value of the max or the min? State the domain and state the range. So go ahead and do that and start the video up again to see how you did. Okay, let's see how you did. Max or min? This parabola has a minimum. It's never going to get lower than that value. It's going to go up forever, so there's no max. But the minimum happens right there. Now the value of the minimum is always the y value of the vertex. Always, always. So this, the value is going to be minus 350. So let's answer these. We have a min, and it is negative 350. That's our minimum. Okay, these next 2 questions are pretty straightforward. State the domain and the range. With quadratic equations, the domain is always negative infinity to positive infinity. You can also just say all real numbers, like that. Okay? Either one of those is fine with me. Now the range is the one that's a little bit more complicated. You have to decide whether it has a max or a min, or you have to use that to answer this question. So, do we have a limit on the minimum or on the maximum end? And the answer is on the minimum. We'll never get lower than 350 or negative 350. So it's negative 350, comma, infinity. The y value can go all the way up to infinity, no problem with that, but it just, the y value in this function, this weirdo decimal function, will never be less than 350. Let's do another one. This one's a little bit more simple, not quite as many questions or moving parts. A pretty common situation to model with a quadratic equation. Quadratics describe the path of objects that act under Earth's gravity. Gravity causes a quadratic equation. And so here's our problem. Patrick, this dude, tries to kick a ball over a 2.5 meter high goal that is 13 meters away. So this guy's gonna kick a ball and hopefully get over the top of the goal that's 13 meters away, okay? It's a pretty reasonable question to ask. The vertical height of the goal is modeled, or of the ball, whoops, that should be ball, is modeled by this particular function. 0.1x squared plus 1.5x, where x is horizontal distance and f of x is the vertical distance. Okay? So this function is just saying that for however many feet it goes vertically, it's going to tell us for however many feet it goes horizontally, it's going to tell us what the vertical height of the ball is over the ground. Now we're going to answer two questions. First, we're going to find the max height of the ball, which occurs at the vertex, and that would be a maximum. And that's good to know because, see, our equation has a negative term in front of the x squared, so that means it's a downward facing parabola, which means it has a maximum. And then the question here is, does the ball make it over the goal? Okay, so I'm just going to sketch a quick situation and then we'll jump on the graphing calculator. Here's our picture. There's our ball, right? That ball is following this parabolic path that is modeled by that equation. Now there's a goalpost that's out here at 13 and it's 2.5 meters high. And we don't yet know now whether or not this ball is going to get over the top of that goal or whether it's going to hit the goal and not go over the top. So let's jump on the calculator and answer these two questions. So let's look at this function on the calculator. So again, I'm in the emulator screen, which just gives me the benefit of having the calculator on the left and then having a blow up of the scratch pad in the middle so you can see the results. So the first thing we're going to do is we're going to enter that function that was on the last whiteboard. So go ahead and pause the video and do that. Okay, so here's the graph. Now I want you to position this graph so that it's a good view of the graph. Either zoom in or out or drag the graph to the left or the right. Okay, so all I did is just dragged it a little bit to the right so that we could have the whole thing. It actually was at a good zoom for this one. All right, so now the first question is, what is the maximum height of the ball? So go ahead and pause the video and see if you can figure that out. Okay, let's see how you did. If you remembered, we just need to find the vertex, and the y coordinate is the value of the vertex. You're right. So I'm just going to hit my menu button here, go to trace, analyze graph, and go to maximum. And then I'm going to click on one side of the vertex, go to the other side, and there we go. And I have 5.63 meters is the max height of the ball. Okay, so good. We answered that question. Now, the second question is, does the ball make it over the 13-meter high goal? Now, that one's a little bit more tricky to answer. So let's go ahead and do that. Now, there's a couple ways I can think of to do this, but I think perhaps the easiest one is to use the trace function. So let's go ahead and do that. That's on the graph button again, or on the graph menu, analyze graph, that is. And we go right to trace. So don't go to analyze, just go to trace and then hit trace graph. And notice how this little starry circly thing is right on our vertex. Now I can go over here on the little controller deal and I can move that thing along. And you'll notice down in the lower right corner of the scratch pad, it's giving us the coordinates of our graph trace. I'm just going to keep clicking that little button, and I'm scooting along, and I want to get to the x value of 13. That's our goal. It's 13 meters away. This is a spot where it's being picked from, flying through the air, and at some point it's going to pass 13 meters horizontal distance, and we need to know if it's going to clear a 2.5 meter high goal. So when I trace this, when I have the x value at 13, the y value will answer that question for it. So let's go a little further. 12.1, 12.4, 12.7, 13, and guess what? The y value, which is the height at 13 meters, 2.6 meters. So yes, soccer ball or the rugby ball or whatever kind of ball it is, it cleared the goal by 0.1 meters. Now, when I first did this, I noticed that when I was clicking the little buttons on the mouse pad on the calculator, this thing is not moving by 0.1. It's moving by 0.3 each time. So there's a way to get it to go exactly where you want, is just to use the input pad on the calculator over here on the left. If I just click 1, 3 and hit enter, it goes right to that spot. In fact, that's a quick shortcut where if you are starting with on your trace, it's way over here, you could just type in 1, 3, enter, and it goes right to that spot. So that's a shortcut for that. This problem didn't ask you to make a graph, but I'm going to go ahead and finish up by looking at the graph that I would transfer onto my page after I worked that out on the calculator. So here we go. Let's label our axes, x, y, and it was asking for the max height. So I put the vertex right there. Max height is 7.5. If this was a question, there'd be a box in there where you worked on that. You'd want to put that in there, and also put it as 7.5 meters, because you've got to put your units. And then here's this little diagram I drew. Here's that 13-meter distance from where the ball was kicked. Here's the 2.5 meter high goal, and then I marked that point as 13. That's the 13, 2.6. So yes, it clears. So if you had a box that said answer this question, you want to say yes, ball goes over goal. It's kind of a weird question, because if this was soccer, you wouldn't want to shoot over, you'd want to get it in. But maybe this is rugby or some other game where getting over the goal is the thing. Maybe it's a football goal where you've got your goalpost like this, and it's trying to get over the goal. Maybe that's the application of this problem. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. Remember, you can also come back to this video again and watch it for deeper understanding. If you liked or enjoyed the video, please click like or subscribe down below.